Hello everyone. So today we are going to talk about another problem, that is merge sorted arrays. Okay. So let us see the description of what it says. So you are given two integers, two integer arrays, basically num1, nums1, nums2. Okay. Sorted in non-decreasing order. Okay. And two integers are m and n are given. Okay. Representing the number of elements in nums1 and nums2 respectively. Okay. Merge nums1 and nums2 in a single array sorted in non-decreasing order. Okay, the final sorted array should not be written by the function, but instead stored inside the array nums1. Okay, to accommodate this, nums1 has given the length of m plus n. Okay, where the first m element denotes the denotes the element that should be merged, and last n element are set to zeros. Okay, and should be ignored, and nums2 has the length of n. Okay, so this all the information are given. Let us see the example, we'll understand better. So here we have nums1, we are given how many elements are nums1, we are given that in terms of m equals to 3, so only 3 elements are there. Other than that, we have the total size of nums1 will be m plus n. They have given m plus n. Okay, to accommodate the n elements are also in nums1. Okay, so that's why 0 0 0 3 are given, that is nothing but this n, and this n is the number of elements in nums2 2 5 6. Okay, so that they are given, and the output is something like this: 1 2 2 3 5 6. The array we are merging are this, the resultant array is this, with underlined element coming from the nums1. Okay, so these are all the elements they have given, and that is merged into nums1. Okay, and this nums1 has been written. So this is another example, nums1 is given, nums2 is given. Okay, and the nothing but nums1 we have written. Okay, here also example is nums1 is 0 with m0, nums2 is 1 with n1, we are again giving 1. The area merging is this. Okay, this is just an example they have given, and the constants are nums1 dot length is equals to m plus n, which they are already given. Nums2 dot length is n. M can lie from, both of them can lie between 0 to 200. M plus n can be 1 to 200. Okay, and the nums I values can be from minus 10 to the power 9 to 10 to the power 9. Okay, we need to come up with a complexity of order m plus n. Okay, so these are the information that given. Let us try to solve this problem in a brute force approach. So basic example can be very simple. What we can do, we can take two arrays. Okay, we already given two arrays. We can create a third temporary array. Okay, start looping in nums1 and nums2. Okay, take one by one value. If nums1 this I value is smaller, then take into the temporary variable. Okay, and then again keep changing the pointer to the next one. Okay, like this we'll be creating a temporary array and then point to the nums1. Okay, but the problem with that approach is that it is going to be taking more time. Okay, so the time complexity will be, space complexity will be more. Okay, although time complexities will be order of m plus n only. Okay, so that is there. Now let us try to reduce that space complexity also. So let us see the flow there, and then we'll be discussing the code part. Now let us discuss the efficient solution. Okay, so the efficient solution is that instead of going from starting, what we'll do, we'll start from the ending part. Okay, and then we'll just compare and fill that information accordingly. So let us see. So first we are given that it is m and it is n size. So the last index will be nothing but m plus n minus 1 will be getting last index. Okay, so last index will be getting, so in this case it will be nothing but 5. So our pointer 1 is pointing at this position. Now then we have this position, this is nothing but nums1 of minus 1, right? So it is this nums1 of m minus 1 is this position, correct? 0 1 2. So we'll be comparing these two values. First we'll be comparing nums1. If nums2 of n minus 1, okay, if it is greater then this value, and what we'll be doing, we'll be putting this 6 here. Okay, instead of 0 it will be 6 if we have this something like that. Then what we'll be doing, we'll be updating our pointer from here to here, we'll be pointing, and this pointer we don't need now, we'll be pointing here, correct. Then again these values will be compared, this 3 will be compared, this 5 will be compared. So you can see this 5 is greater, so we'll be putting this value here. Okay, and once done, we'll be pointing this here. Okay, after once it is done, now again this is done, we'll be moving a pointer here. Then now you can see 3 is greater than this 2, again same thing will be compared. Okay, so 3 is greater than this 2, so what we'll be doing, we'll be putting this, moving this from here to here. Okay, we'll be putting this from here to here. Now again this value will be moved here. Okay, this is done from here, and now what will be comparing 2 and 2. So you can see 2 and 2 doesn't make any difference, we'll be keeping it is similar to that. Now again this will be moving here. Now again 1 and 2 will be compared, so 2 will be removed from here and 2 will be put here. Okay, and before that 2 was here. So you can see now all the part has been done, and one is remaining still, so 1 will be left as it is, because nums1 is only what we are going to be returning, so no operation is needed for this thing. Okay, so that is simple explanation for the flow. Let us try to implement the code, we will be understanding better. So let us try to code here. So first we are going to be finding the last index. Okay, so suppose the last index will be nothing but m plus n minus 1. Okay, once we have done that, we'll start our iteration from the very end. So we will be writing this two condition, that one m should be greater than 0 and n should be greater than 0 and n should be greater than 0. Okay, for both of the condition. Now first condition is that if our nums 1 of m minus 1 is greater than nums of, that is nums 2 of n minus 1, then what we are going to be updating, we would be updating our nums 1 of the last part is nothing but last index, that is last index, right? So last index will be putting this value, which value will be putting, which one is greater. Okay, so last index equals to nums 1 of m minus 1. Okay, so that value will be putting. Now what we'll be doing, we'll be reducing our last index by 1. Last index equals to last index minus 1. Okay, and we'll also be doing m, we'll be also be reducing m, right, because we have already done with that, right? So we can do minus here also, and we can also do that here also. Okay, now once we have done that, we'll be going into the else part. Else part is the case where nums, this value is greater than this value is greater than nums 1 value. So for that case, what we'll be doing, we'll be putting nums 1, okay, last index equals to nums 2 of n minus 1. We'll be reducing our last index by 1 and we'll be reducing our n by 1. Okay, once we have done, now there will be two part, either can be their values can be left in the nums 1 or nums 2. Nums 1 we don't care because it is going to be returned from there only, but for nums if we have some values in nums 2, then we need to put those values one by one, correct? So we'll just be coming out of this loop. Okay, so while n is still greater than 0, okay, if it is still greater than 0, okay, so then what we'll be doing, we'll be putting nums1 of n minus 1, basically nums1 of last index will be there, equals to nums1 of equals to nums2 of n minus 1. Okay, we'll be reducing our last index by 1 and our n minus minus. Okay, so that is done, and we did not do anything other because it's a void function. So let us try to run the code and see the output for this. So it's had been successfully accepted. Okay, I just need to log in. Okay, so that's it for this video. I hope you got the idea for this problem. Thank you for watching. We'll meet another with the next problem.